Okay, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1203. Hopefully you guys are all doing well. I was waiting around for some more people to join. I think we're missing 5-ish people, which I guess is a lot. That's kind of going to mess up the plan a little bit, but we will move ahead. If they come in afterwards, I guess I'll try to do something else. So what I wanted to do, I actually wanted us to start out with a little activity today. So that's why I wanted to kind of give everyone a chance to join. But let's just remind ourselves of where we were. So I covered these announcements last time, so hopefully you remember those. We were looking at exponentials and logarithms. So we did exponentials. We kind of have an intuitive understanding of what that means. Looked at the laws of exponentials. We looked at the graphs of exponentials. We compared exponentials to polynomials, and we understood that exponentials grow faster than polynomials. And they also decrease faster than polynomials. So if exponential is increasing and a polynomial is increasing, the exponential is eventually going to win. If they're both decreasing, the exponential is going to win that too. Except the exponential probably won't go negative, but it will shoot down to its lowest value relatively quickly. We compare them. In the short term, you might not actually notice the difference, but in the long term is where the exponential really takes off. And an important exponential function is what we call the natural exponential. And this has base e. E is actually a constant, 2.71828. It was a number that Euler, the mathematician Euler, found to high precision when he was considering this really ideal, something that couldn't really happen in reality case, hitting you with 100% interest on $1 an infinite number of times per year and then figuring out how much money you have at the end of the year. Turns out you'd have E dollars. Now, of course, in reality, we can't actually compound something an infinite times per year, but obviously knowing what that value is kind of tells us what the boundary point is, the kind of worst case or best case scenario. So that was important. Then we started talking about logarithms, because sometimes it's not raising something to a power that we care about. We actually care about the power itself. How do we actually solve for that is an issue. To get to that, we invented the concept of a logarithm, and we went over the log rules, which I asked you guys to memorize and look over. Okay, and we looked at some notation for that. Now, it turns out that these two guys are very important. These are the guys that tell us that we can use logs to cancel exponentials and exponentials to use logs. In fact, I probably want to make a bigger note of that. So let me actually move on to what we're going to do today. And some exercises here for you guys to try, but maybe I'll just take some time right now to make some notes. I don't know, maybe I'll just move these out of the way. That'd be nicer. And then I'll move them back. I'll give you guys the time to copy that later. Okay, so we are going to continue with more on exponentials and logarithms, and then we're going to do some examples where we play around with them, see how they work, etc. But I just want you to recall this I told you about last time, how if we have log to the base e, we write that as ln. So whenever you see ln, it's just a logarithm where the base is e, this very, very important number. If I just write log and I don't mention a base, it really means base 10. So that's something that you should also be aware of. That's super common. So science, engineering, finance, almost everybody else pretty much uses base 10 as the standard logarithm. Mathematicians use base E as a standard logarithm because it actually makes a lot of math and theory work out nicer. And you will see that we even use base E to derive a lot of our formulas in calculus, even though I'm not going to derive everything. I'm going to kind of show you how the exponential function is important in that regard. However, so LOG just really means the standard logarithm. For most people, this means base 10. If you are in advanced mathematics, you see LOG, it means base E. If you're in advanced computer science and you see base log, it means base 2, right? So it's discipline specific, but most people will think base 10 when they just see a log. Now, laws 8 and 9, I just want to say a little bit more about that. So 8 was the rule that said, I believe, log to the base a of a to the x equals x. And 9 was the one that said a raised to the log to the base a of x equals x. Tell us that the functions y equals a to the x and y equals log to the base a of x are, based on these rules, what do they tell us? Saying that log to the base a of a to the x equals x and that a to the log to the base a of x equals x, what are those two facts together? What do they mean? What do they imply? What is the mathematical term for what that statement means for these two functions? Anyone remember the language we use? Inverse. It means they're inverse functions of each other. Now that's good because this means two things right away. One, we will automatically know how to draw the graph of a logarithm just by knowing how to draw the graph of an exponential. So we don't even have to figure out and plot points and stuff like that. We'll know the graph right away because the graph of an inverse you obtain by reflecting the graph of the original function over the line y equals x, like a mirror image. So it means we automatically know the graph. So that's good. It also means computationally speaking, we can use one type of function to cancel the other. So just like how when we were solving equations, if you were to have something like x plus 2 equals 5 and you want to solve for x, you understand that, okay, there's a plus 2 on this side. I need to get rid of that so I can isolate the x. What is the opposite of plus 2? You know it's minus 2. You have to subtract, right? So you know that subtraction is like an inverse operation for addition. In that same way, analogously, if something is raised into power and there's an exponentiation and you want to know, I want to isolate the power. How do I get rid of the exponential? The logarithm is the answer, and vice versa. So it's like an inverse operation for each other. So you can cancel exponentials with logs. You can cancel logs with exponentials, essentially cancel, according to certain rules. And the rules specifically are described in these formulas here, which means you have to have one plugged into the other directly, right? So there's this, the a to the x, if you plug that into a log, the log is going to cancel the exponential base and it just gives you the power. And if I plug in the log in the power of an exponential, it cancels the exponential operation and just gives you what's inside, right? So that's like your f of g of x equals x and your g of f of x equals x. We call that inverses. And that gives us a lot of, this has implications for the graphs and calculations. So for example, we know how the exponential looks like that, right? So let's say, you know, you have an exponential, a greater than 1, then what would the logarithm look like? Well, you would look at the line y equals x, and you would just take the mirror image of the red curve, and you would get this blue curve. That blue curve passes through 1, just as how this red curve passes through 1. It's like the output becomes the input, etc. So I know what the graph of a logarithm is right away, immediately, once I know what the graph of an exponential is. So that's one nice thing we get from knowing about the exponentials. So I know that the graph, at the moment we're focused on logarithms. So let's actually just look at the graphs of logarithms. What does y equals log to the base a of x look like? Well, looks like so. And if oh, the sun came out, just, it was overcast the whole time. I normally have like a little shade here, but and what does the graph of, keep the pattern we had last time, negative x looks like? Well, that just means you reflect, in vertical. That is -1. And if I were to look at what does y equals log, maybe I should draw this differently. It looks kind of weird. And the behaviors are very similar. The same way the exponential gets close to the x-axis but never touches it, this guy gets close to the y-axis but never touches it, by the way. The behavior is exactly a mirror image copy. If I take the negative, the log, then of course, you know, that just flips it upside down. So that's going to look like this. And if I take the negative of the outside and change the input to negative, it's going to look like that. So those are the graphs of the logarithms, right? Okay, and just knowing that they're inverses and of each other makes us know how to draw the graphs. So that's cool. Let's come down. Also, 8 and 9 mean, and we're going to get a more appreciation for what this is, but just to like say it in words, because it's always good to talk about math, we can use exponentials to cancel logs and vice versa. In the kind of sense that you can use subtraction to cancel addition, you can use division to cancel multiplication, etc. You want to undo one, you can use the other. Okay, so that's very important when it comes to solving equations. Now you have to be careful of how you do this. Of course, there are rules to this thing, but you should just know this as a general concept. If I see an exponential and I want to get rid of it, a logarithm should be the obvious idea. If I see a logarithm and I want to get rid of it, the exponential should be the obvious idea. Okay, but of course you have to make sure you apply these rules correctly. The devil is in the details, but that's basically it. So we looked at what logarithms are and the rules and the notations, and these are what the graphs look like. Here's another important fact. Just to expand on something that we looked at before, and we're actually going to expand on that a little bit even later. So I'm not going to write out everything. I'm just going to use the notation that we used last time. And that was, we mentioned last time that, you know, an exponential is going to beat a polynomial, right? So this, a is greater than 1, x is getting huge, going off to infinity. The exponential is going to win. Where does the logarithm fall in this totem pole? Well, the logarithm is the one all the way down at the bottom. In the sense that the same relationship that we saw between exponentials and polynomials, that same kind of relationship exists between polynomials and logarithms. So just as how when we're going to infinity, an exponential is way up here and the polynomial is like effectively 0, might as well not even try. If we now zoom down on the polynomial and look at it as a scale where the polynomial is way up here, then the logarithm is effectively 0, might as well not even try. So polynomials will beat logarithms and exponentials will beat polynomials. There's a hierarchy of these functions when they start to increase. When the inputs get large, they really start to, the gap between these functions really start to increase so that guys on the left, they're effectively 0 compared to guys on the right. Okay, so that's important. And we're going to use that all the time, actually. So that's an important fact. Now what I want to do is I want to actually get you guys doing some problems. So I will go through this with you guys, but I would like you guys to actually take a crack at it first. And at this point, I'm going to kill 2 birds with 1 stone. So I am going to try to get something else done that I want to get done while we are doing this. And that is to just get the class into more cohesive, sociable structures. Okay, so there are about 16 of you. Maybe I can have 4 of you work together. Okay, so I'm going to put you guys into groups, into breakout rooms. I would like group 1 to tackle this problem. Group 2 to tackle this problem. Group 3 tackles 3 and up to here. And group 4 tackles here. Okay, so you can take a picture and just so you know what you have to do, because I'm going to put you guys in another room and you probably won't see this. So here is the plan. I am going to give you guys about 10 minutes on this stuff. Now, the first 1 minute, what I would like you guys to do is to exchange contact information. You guys can all say your emails or your cell phone numbers and get into a WhatsApp group or something, but I would like you to get a group going of people that you can study with and ask questions and reach out to if need be. So that's the first thing, but don't take like more than a minute on this. Just hurry up. Oh, here's our contact information. Or maybe you guys can just designate someone that will collect it. That person will throw their email. Everyone emails that person and you can set up some contacts later. So that's the first minute. For the other 9 minutes, I want you to actually do the problems that are prescribed here by the groups. Okay. And so what I will do is I'm going to randomly split you into groups. I think later in the semester, I will be putting you guys into groups again, but that one is not going to be random. I'm going to kind of choose. But this is just to get things started. Okay. So take note of your groups. So Claudia, Emily, James, Mikhailo would be in group 1. Christopher, Joseph, Mary, Tio, group 2. Gabriella, Isaac, Samantha, Sokol, group 3. Anthony, Brian, Michaela, Skribahava?
Sri Bhavana. But I
Oh,
go by Bhavana.
What?
I go by Bhavana, but my full name's Sri Bhavana.
Bhavana. Okay, yeah. I'm gonna work on the first one, but you go by Abhana?
I go by Bhavana.
Bhavana. Okay. Okay. Yeah, you guys are in group 4. Okay. So take a picture of the problems you guys are going to work on, and I will let you guys work on it. So, like I said, the first minute, find a way to efficiently exchange contact information. Try to set up like some context going, and then for the rest of the time, you're going to work on the prescribed problems as are in the notes here. You won't be able to see this, so you should take a picture or quickly write them down if you haven't already. And then I'm going to move you guys into the groups. So you should, at this point, see an invite on your screen where you can join your respective groups. And I will see you guys in about 10 minutes. I will pull you back here. And I guess I'll stop recording, so I'll see the rest of you in about 10 minutes.
I tried looking for it yesterday.
I did. Okay, so we're back. Let me actually get you that link. I'll paste it in the chat.
Perfect. Thank you.
So our class has a website, and that's at that link you can get everything. You can get the syllabus, you can get links to the videos and the notes. You can get you can see some old quizzes and tests. You can see reviews for tests and stuff. So yeah, that's probably the link you want.
Yeah.
So let me paste it in the chat here. I just was finding it on my browser. Okay, there you go.
Thank you.
So I know I've been getting some new students during this week. So if any of you are new, you probably don't have that link because I don't think I posted it on Blackboard, although I probably should, like post it in an announcement or something. But yeah, going there, you'll find all the material that you will need for this class and be able to watch lectures that you missed and see notes and all that good stuff. Okay, let's see how far we got. Guesses. Just want to see what you guys got. So group 1, part A, what do you think?
1/2.
You think the answer is a half? What about this one?
3.
Thought the answer is 3. This one? Did you guys get it? Or you were still working on that one?
We're still working on it.
Okay, so didn't get there. Okay, valiant effort. Let's see. Group 2, you had one big problem. Did you guys figure it out?
Kinda. I got to like the expansion, but then I didn't.
Yeah, well, what did you get?
So I got to the top part still being x2 minus 2, and then the bottom part being x4 plus 9, or 9 x to the power of 4 plus 9x to the power of 3 plus 27x to the power of 2 plus 27x.
So 4 plus 9x to the power of 3 plus
27x to the power of 2, and then plus 27x. I think.
Okay, and that's all still over here?
Yes.
And then what?
That's kind of as far as I got.
Okay. And why is I? There's no I in team. Where's the rest of group 2? Like, weren't you guys working together? Right now, we just made him do everything, and that's where he got. So that's where our group got.
I think
Is that
I think one of the people's mics weren't working, but yeah.
Okay, group 3. How far did you get?
We got
Do
all
you
the
got
way
this?
through. Yeah.
Okay. What do you think this is?
We thought it was I'm sorry if I say it wrong. I said log x squared base 2
Log base 2 of
x squared.
x squared?
Yeah.
Okay. You say the base first. Log base 2 of x squared.
Okay.
What about this guy right here?
If someone else wants to be in the group to chime in.
Yeah, that one would be I think it was x to the natural log of 12. ln x.
I
ln,
mean, you want to solve for x, so it's ln of
yeah, 12.
12. Okay, or you can just write that as ln 12. This one?
We got x equals e to the 9th.
Did you guys get here?
Yes.
What did you get?
Negative ln parentheses 4 parentheses negative 5, and the whole thing was divided by 3.
Okay. Group 4?
We ran into a lot of trouble with these, so
Okay. Did you get anywhere with D?
no.
Okay. Did you guys jump to E?
I mean, no.
We
We
attempted
tried,
all of
but
them, but we didn't really get far.
Okay.
Like we all genuinely, we tried.
Okay, that's good. All right. Well, it's good that at least, I don't know how many of the other groups, because some of these problems are easier than others, but I don't know if the other group had tried this, how they would have done, but trying is all I can ask you to do. Let's actually see, though, what these guys actually, what they actually are. So let's copy these. Now, of course, we're not going to finish them. We're going to start them. And hopefully by the end of this, things would be cleared up. And when I was doing in-person classes, I didn't do like this break room scenario. So we struggled in class together. And if you want to watch those old lectures, you can see the common mistakes that would pop up. And it's kind of like the mistakes that I was mentioning before, not paying attention to notation and all that stuff. Well, let's actually just go through this. Okay, now there are a few ways you can do all of these. There are multiple ways to actually get through all of these problems. And I'll show how I would do it, or maybe even a couple ways to do it. And if you guys tried a different way, you can let me know, what if we did this? Would that be okay? And I'll answer you. But many ways to do this one. So for example, I could realize that this just means by the laws of exponents, I could move the -1 off to the side. So this is because, x to the a raised to the b equals x to the ab, right? So basically we had the right side situation and I factored the b off. Now on the inside, e to the ln of 2, well, that's just 2, right? And that was because of the rule, if I have a log to the base a of x, it just gets x. That also means, of course, if I have e log to the base e of x, that's just x, which in other words just means e to the ln of x gives me x, right? So the e and the ln right beside each other can cancel each other out. A very common mistake would be to do this when you're not allowed to do it, and I'll give you an example. So you get 2 to the minus 1, which is a half, and that is the answer. And I believe that's what the group said. Yeah, so good job there. But there were other ways to do this. So another way, we could have started with e to the minus ln 2, and we could do something like the following. Move the minus 1 up in the power. And this is because we have a rule that says if I have something in front of a log, I can move it up and put it as a power. So here I had a minus 1 in front of this log. I can take the minus 1 and move it up as a power of the thing inside the log. So this is all inside the log right here. And then I apply the same rule. E to the ln of something is just the thing. So I get the 2 to the minus 1 again, and that is a half. So tons of ways to do that. And again, that's because of this rule. I just know because e to the ln of anything is just going to be the thing. We get 1/2 as the answer again. So that was 1/2. Tons of ways to do it. I would say a common mistake is to do something like the following. So make sure that if you thought about doing this, you should know that it's not the thing you want to do. They would see something like e to the minus ln 2, and they just have that rule. Oh, e's and ln's cancel each other, right? And then they would cancel the e and the ln right away, and then they'll write the answer as minus 2, but that is incorrect. And you might want to know, well, why would that be incorrect? Because I was thinking of doing something like that. Well, it's because the rule says if we have e to the ln of something, we get the thing. And here, what we have was e to the minus ln of 2. And it matters that there is something in this position that was not in the other position. Which means the rule does not immediately apply because you're not in the right form. Okay, so you have to be very careful. The rules, they are your templates. To be able to apply them, you pretty much have to be able to take what problem you're looking at and like fit it right on top of the rule, and everything should be in the right position. If it's not, if there's anything out of place, if there's a number in front of the ln, you can't apply this rule. You need to get rid of that number somehow. And what I did is, one option to get rid of that number is to move it up according to a log rule that we have. Another option to move that number is just factor it off using the laws of exponential. So I can use either a log trick or an exponential trick to move stuff, but the important thing is to know I have to move stuff, right? That -1 in front is an issue, and you should recognize it as an issue because it doesn't match the formulas very well. So back when I was giving you, where are we? So when I'm giving you all these rules, it's very important that you know them and you know them exactly as written. You need to notice that, oh, there's nothing in front of here, or there's nothing over here, or this is a variable, not a constant. This is a constant, not a variable. Like things like that, you need to recognize, right? You need to really pay attention to detail. Otherwise, you're going to get into a lot of trouble. So just move the pictures in the way. So just for you to be aware of that. So a lot of people get in trouble, and that's just because they're just not paying enough attention. They kind of learn the rules, but they don't really learn the rules. And this is what's responsible for things like distributing powers across sums, for example, because they understand they could distribute a multiple across sums, and they didn't really pay attention to the fact that, oh, it has to be a multiple and not a power. And so they get into this natural mistake, and then it just feels right because you do similar things, but the context matters and where things are written matters. So notation matters, right? I gave that whole speech last time. So that's how part A could have been done. And we'll just get through these other two here. what I would do is, since most of you guys didn't even finish right away, I would say to actually attempt doing some more. Attempt the groups who didn't give me any guesses. Try them again, and we will see on Tuesday how you guys go. So like I said, very fine. It's okay to discuss with your group. Hopefully you guys got everyone's contact information. Actually sit down and figure it out. Now, as I said, I've given these examples before, so technically you could look up what I did, but I would encourage you not to. Actually try to hash it out amongst each other and exchange ideas and figure it out that way. As well as you could use a calculator to do some of these. I would encourage you not to, because you're going to get in trouble when test or quiz time comes around, and actually get through them. So try to get through all the problems you didn't get through by next week. Do your best attempt, and we'll see what happens. This one is going to be similar. Because we know e to the ln, we can kind of think of these as canceling each other. And so we get ln of e cubed. And we can also now, tons of ways to do this. I know the e and the ln would cancel each other. And then that just leaves me with 3. So that's the answer. Or tons of ways you could do this. I could first have, you know, I could first cancel these, and then I would get ln of e to the 3, and then I might feel like moving the 3 down in front, and then I have 3 ln of e, and then you might think, what is ln of e? Well, the base is e. What power do I have to raise e to in order to get e? The answer is going to be 1, and so that's 3. In fact, this is another kind of general rule that you can know, although you don't have to memorize it. Log to the base a of a is just 1, right? Because you have to raise a to the power 1 to get 1. And again, many other ways to do this. You can have solutions looking different ways, but make sure you pay attention to the rules, and you will get you will do the right thing. Now, this one kind of mixed some people up, understandable. But again, look at what you have. You have a base e and you have a subtraction in the power. There's tons of ways you can actually deal with this. One is to just remember, what does subtraction in the power mean? It means you're dividing things of the same base. So you can split into that. Using the rules I mentioned before, e can cancel the ln. So that's just x squared in the top. Notice that I cannot do that in the denominator because the 5 is in the way. Notice that the 5 is in the way. So the rule does not apply yet. What do I do? Well, get the 5 out of the way, right? So I would take a step here and move the 5 up to the power. And now I can get rid of that. And so this is x squared y to the 5th. And so that's what that would look like, right? But again, tons of ways you can do this. It just matters which rule you see first. Different people see different things. You could actually look at this as the addition of power. Just think of that as multiplied by e to the minus 5 ln y. Then you'll realize that this guy cancels. So that becomes x squared. You'd also realize that, oh, I need to move that 5 out of the way up. So this would give you e to the ln of y to the minus 5. Then you cancel that. So you get x squared times y to the minus 5. And of course, you can simplify that to get to the same answer. Okay. So it comes down to knowing the rules very well, knowing all the micro details. It's very detailed oriented. And I will just say for this one, when I say expand, I mean expand the logarithms. I mean, go from something like this situation to something like that situation. Right? So expand does not mean to expand actually start expanding the polynomials. In fact, you definitely do not want to do that. Okay? So knowing that you're not allowed to do that, what would you do? What are the other options you have? Look at the rules of logarithms and figure something out that can get you to work something out very nicely. So we will stop there. I will post all these in the notes, but I encourage you guys to meet up over the weekend and figure some stuff out. This is going to be relevant for the quiz and your homework. So you should definitely get to working on that. Yeah, and with that being said, we can wrap up. Any questions before we go? Or we good?
Just one thing on C. If you wanted to move the 5 into the exponent, can you leave the subtraction symbol, and then that would give you division, which would give you x squared over y to the 5th. But then they just cancel
Yeah,
out.
you have to be careful though. You mean like move the keep this as e to the minus ln and move the 5?
I had e ln x squared minus ln y to the 5th,
Hold on.
and then I just
So
did
your first
e
rule was
ln,
e ln x squared, like this.
all in the exponent minus ln y to the 5th,
Okay, and
and
then
then e ln parentheses x squared over y to the 5th close parentheses, and then
yeah,
cancel the e and ln, and then that just leaves you with x squared over y to the 5th.
yeah, that is correct.
Okay.
The steps there are correct. Like I said, there are tons of ways to do these. So you use the rule that tells you can combine logs. If I see log of something minus log of something else, it means log of the division. And so you just combine it into one big log and then cancel the rule. That's totally fine. Yeah, this is fine.
Thank you.
Okay.
Professor, quick question.
Yeah.
Where would the quiz for this weekend be posted?
On Gradescope.
Okay, thank you.
So if you didn't get emails from Gradescope, it's a big deal now. So make sure to reach out to me and I will take care of that today or early tomorrow.
And we have to be online for 9 a.m. for that, right?
Yeah. You would log into Gradescope for that.
Okay. And are
You're
we
gonna log into
uploading?
Gradescope, you'll see quiz 1 and you just click on it and you take it.
Okay. Is there anything to upload like work-wise or just?
No, not for quizzes. For the
Okay.
tests and the final, you're gonna have to upload things. And at that point, I'll give you like just a fake test for you to practice uploading and stuff like that. So you'll be used to doing it by then.
Okay. So just multiple choice for the
Yeah,
quiz.
multiple choice, maybe short answer, fill in the blank, stuff like that.
Okay.
But you don't have to show work for quizzes. I'll just grade the answers right there.
Thank you.
Okay, all right. With that being said, have any more questions, email me, especially if you didn't get all my emails from 4 different sources, you should. And I guess good luck on the quiz, and I will see you guys on Tuesday. Ciao.